Hello boys and girls. This is Professor Nelson of Electronics. This time, we're going to make a very interesting tool that many of you will surely be able to use at work. A tool that can do things our multimeter can't. So, I invite you to stay until the end of the video to see our tool. For this, we're going to need a cell phone charger. The brand of your cell phone charger doesn't matter. It could be Xiaomi, or it could be Samsung, or it could be Sony. The brand doesn't matter. The important thing is that your charger works. So, without further ado, let's see what it's all about. Okay, the first thing we're going to do is remove the cell phone charger's electronic board. We carefully remove the board. This would be the cell phone charger's electronic board. These types of boards work the same way as the boards in switching power supplies. And charger boards usually have a Zener diode like this one here, from 5, 9, or 12 volts. This determines the output voltage of the power supply. However, sometimes chargers, as well as switching power supplies, often have a programmable Zener diode. As is the case with the TL431, this one here. In the case of this power supply, we can see that this would be 431. However, on our cell phone charger, we have it right here. And as you can see, it says 431. That's a programmable Zener diode, which we'll have to replace with a regular Zener diode in order to raise the voltage of our charger. Well, for that, let's look at some theory. Okay, now for some theory. Now on our electronics board, we have the TL431 in SMD format, where pin 1 is the reference, pin 2 is the cathode, and pin 3 is the anode. And the connections would be more or less these, where we have pin 3 of the TL431, or cathode. It's connected to the cathode of the LED of the optocoupler, and the anode is connected to the negative. What the programmable Zener diode does is activate at the voltage that was programmed through this potentiometer, or through this integrated circuit. This means that when the output voltage reaches the programmed voltage, the LED will activate, and then the transistor will activate, causing the rest of the circuit to stop increasing the output voltage. Therefore, that's how the TL431 works. However, what we want is to have a different voltage than the one already programmed. Therefore, what we're going to do is replace this programmable Zener diode with a normal Zener diode. That is, with this Zener diode, whether it's 5, 10, 15, or 30 volts. For this, the connections would be these here. We're going to connect the Zener diode directly, the cathode to the cathode, and the anode to the negative, nothing else. And then verify that at the output we have the voltage indicated by the Zener diode, added to the necessary voltage of the LED. That is, if I input 5 volts plus 1 volt, I'll have 6 volts here. That would be the whole theory. Now let's verify all this in practice. Okay, the first thing we're going to do is remove the TL431. Okay, now we're going to insert a Zener diode. This one here is 4.7 volts. Cathode has to go to cathode. Remember that in the case of the programmable diode, the cathode is pin 2, and the anode is pin 3. Cathode, anode. Very good. Now let's test the output voltage of our charger. It should give us approximately 6 volts. Very good. Now let's test our modified charger. We connect it to the power outlet. We're going to use a USB cable. Our voltmeter has to be set to DC voltage. Negative to negative. And positive to positive. There we have 6 volts. That means the modification was a success. So, now we're going to modify it so that our charger can deliver 25 or 27 volts. So let's make that modification. Okay, first, we're going to remove the Zener diode. Now we're going to install 2 diodes, one 10 volts and one 15 volts, so that together they give us 25 volts. If you have a 25 volt one, you can put it in, but the voltage must not exceed 25 volts. I'll explain why later. Remember cathode, anode. Okay, we're done. We have the 10 volt and 15 volt Zener diodes. We would have a 25 volt output. Now, keep in mind that we'll have a 25 volt output, which means we have to modify a few other things. And I'm referring to the capacitors. Here you can see that we have 2 10-volt capacitors with 470 microfarads. We have to replace these capacitors with one that's higher than 27 volts. The capacitance may be the same or it may be lower. There won't be any problem if the capacitance is lower. For example, in my case, I'm going to use a 35 volt, 100 microfarad capacitor. Just one instead of 2. The other issue is the Schottky diode on the electronic board. In this case, it's the SR5100, which can operate up to 100 volts at 5 amps. Take into account the maximum voltage at which the diode can operate. If it can't operate above 30 volts, then it needs to be replaced. In my case, it's not necessary. Therefore, I only need to replace the 2 capacitors. So I can run the tests again later via USB. Okay, now we've modified our charger. Now, let's add a voltmeter. One of these. This has 3 wires, allowing us to power it through an independent power supply. And measure the voltage across the yellow wire, the test voltage. I'll show you the circuit right away, showing how it should be connected to our charger. However, before that, let's remove the USB connector. Okay, the connections for the voltmeter we're using would be these here. Normally, a voltmeter like this has a yellow wire instead of a green one, but I used this green wire. Now, the connections would be as follows. The red wire is positive to the 27 volts supplied by our cell phone charger. The black wire is negative, and the green wire toward the component or load we're going to measure. Between the red wire and the green wire, there will need to be a 4.7 kilo quarter-watt resistor, like this one here. Now, to measure the component or load, we'll have to use the leads of a multimeter you're not using. The black one will go directly to negative, and the red one will have to be connected to the green wire, or to the end of the resistor. Well, those would be the connections. Let's make the connections and then test the equipment. Very good. Now that we've finished making the connections, let's apply glue so the wires don't move. Ready? Now we wait for the glue to dry. Very good. Once the glue has dried, we can test our modified board. We put it together. Ready. Now we have to plug it into the power outlet. There we can see the voltage. It's 25 volts. And if we touch the leads, 0 volts. Okay, now let's finish putting it together properly so we can test it with the components. Okay, guys, now that we've finished our measuring tool, look how it turned out. It turned out very well. Now let's test it by measuring some components. We have 25 volts. Now for something very important. According to the data sheet, the voltmeter must be powered with a voltage less than 30 volts. That's why we're using 25 volts, not 30 volts, or a higher voltage. 25 volts are enough to measure many components, such as an LED. There we have 1.85 volts, which is fine for an LED. We also have Zener diodes. In the case of Zener diodes, these must be measured in reverse. The cathode is positive, and the anode is negative. That's a 4.7 volt Zener diode. If I measure it forward in reverse, it will measure like a normal diode. We have a 0.7 volt drop. Here I have another Zener diode. Always remember to measure in reverse. Cathode to positive and anode to negative. This is a 10 volt Zener diode. The other way around is 0.7 volts. Here I have another Zener. It's a 15 volt one. In the same way, you can use the tool to measure the status of the LEDs in the light bulbs when you need to repair them. We have a 5 volt drop from 10 volts, from 15 volts. It doesn't turn on. This LED is burned out. So, this way, you can use the measuring tool. Our tool can deliver more voltage than the multimeter can, which is why it's quite useful. Well, this way I would conclude the video. Now, don't forget that if you like the video, a like helps the channel a lot. See you in the next video. Bye-bye.